Welcome to the first video of section 9.3. So in this section, we are going to be looking at finding the trig functions of any angle. So we're going to be looking at lots of different angles here, and we're not triangles. We're going to be looking at angles in the coordinate plane and seeing how that information, we can take that and find the trig functions of all of those. So let's look at our problem here first. So here you see we've got a diagram. We've got our coordinate plane, and then we've got an angle here for us. You see our initial side is on the positive x-axis, and the terminal side is over here in quadrant 2. And we have a circle drawn around this, and we have a point at negative 4, 3. Now let's read the problem. Let negative 4, 3 be a point on the terminal side of an angle theta in standard position. Evaluate the 6 trigonometric functions of theta. All right, so here's our angle right here. Here's theta. And if you look at this diagram, you see R. R is going to be the distance from the origin out to the point, negative 4, 3. Okay, now there's a couple formulas that we're going to use. So let's go, and I'm going to show you a page in the journal that gives you all these formulas. And you're going to need to write these down because we're going to be using them for the problem. So here we go right here. So we're using something called the unit circle to define the trig functions. So we're going to get into the unit circle a little bit later, but let's look at these. The ones that we want to look at are these 3 functions right here. Remember, we're not going to worry about the cosecant, secant, and cotangent. All right, so here's our situation. Let theta be an angle in standard position with xy a point on the terminal side of theta. So this is setting up just like our problem. And r, which is the distance from the origin to our point, is just equal to the square root of x squared plus y squared. Now you've seen this before, probably in Algebra 1 or definitely in geometry. This is just the distance formula right here. Okay, so we've got our distance from the origin to a point is just the square root of x squared plus y squared. And here's our rules right here. Here's our 3 trig functions. So we know that the sine of our angle is going to be our y coordinate divided by the length of r. Our cosine is our x coordinate divided by the length of r. And our tangent is just y over x, and that's our y point divided by our x point. Okay, so our y value divided by x value. So your 3 variables right here are x, y, you get those from your coordinate, and then r. R is the distance from the origin to your point. Okay, so again, these are the 3 formulas that we need, and to find r, we need this formula right here. Okay, so these are going to be the ones that we use to solve this first problem. So again, you want to make sure you're writing these down so that you have them. Let's go back to our problem. So let negative 4, 3 be a point on the terminal side of an angle in standard position. Evaluate the 6 trig functions of theta. All right, well, first thing we need to do is we need to figure out what r is. So remember, r is just the square root of x squared plus y squared. Okay, and we get x and y from our point. So here we've got x equals negative 4, and we've got y equals to 3. Okay, so again, all we're doing right now, I haven't done any work. I've just taken our 2 values from our coordinate point, and I've written down our formula for r. So if we take r and we plug in x and y, we end up getting, it's the square root of negative 4. Remember, the negatives are important. You have to include the signs with it. So negative 4 squared plus 3 squared. Now, when you go ahead and do this, negative 4 squared is 16, and 3 squared is 9. So you're going to get r equals the square root of 16 plus 9, which is 25. and we get r equals to 5. So that's our first step right there. We have to figure out what r is. Okay, because remember, all three of our formulas, our sine, cosine, and tangent, require us to know x, y, and r. So if we go back and we think about our formulas, now we're only going to do the 3 trigonometric functions. We're not worried about the other 3. So remember our formula. The sine of theta, there's my theta drawing, is just equal to y over r. And that's the formula that you just wrote down. The cosine of theta is equal to x over r. So what I'm doing right now is I'm just writing down our formulas. We're going to plug in the numbers in a second. So it's equal to x over r. And finally, the tangent of theta is equal to, remember this one right here, you don't need r for tangent. This is just y over x. Okay, so again, to this point, we haven't really done a lot of work. We've just written down, we've got our formula to find the distance, r, to our point, and then we've got our formulas for our 3 trig functions. So now, let's just go ahead and solve these. So for the sine, it's y over r. We know y equals 3, so it's just 3 over r is 5. So 3/5. Cosine is x over r. So remember, x is -4. So again, you always have to include the negative. So -4 over 5. And then our tangent is just y over x. So y is 3 and x is -4. So this is just going to be -3 over 4. And that's it right there. That's all you do to find your trig functions when you have an angle in standard position. So remember, you have to find r by using the distance formula, and the x and y values come directly from your point. And be careful to include the negatives. If you have a negative coordinate, you have to have a negative in wherever you put it in with your variables. Okay, so that's how you find the 3 trig functions of an angle when you've got a point that lies on the terminal side. Okay, now you can come back. This is going to erase for a second because I've got to go back to the other page. You can always pause this. You should write this down so you've got it in your notes. You're going to need these formulas right here to do the next problem. Okay, so what I want you guys to do right now is let's look at this extra example. So here's your point. Let 8, -6 be a point on the terminal side of an angle theta in standard position. Evaluate the 6 trig functions. So what I want you to do, again, not 6. For us, it's going to be 3. Evaluate the 3 trig functions. So that's sine, cosine, and tangent. Okay, just like we did in that problem, I want you to write all 3 of those in the answer box. So I want to know the sine of theta, the cosine of theta, and the tangent of theta. If you have any questions, just go rewind back 2 minutes, 3 minutes, and just rewatch that problem. It's very simple to go through. Go ahead and enter it in the text box now.